All right, let's get started. Good evening, ladies and gentlemen. Welcome to the Python Meetup tonight. We have a Slack channel, if you can see at the bottom here. So if you haven't joined, please do so. And there are like channels for opportunities and introductions, and feel free to join and say hi there. Uh, okay, I would like to first thanks our collaboration teammate. I'll pass it on to you, Rich. You can give
Oh,
a short introduction.
sure. Yeah. So Teamit is sponsors some of the Meetup group. I work for the company called Teamit, and we've been recruiting remote teams for the past couple years. And as you can imagine, remote work is really taking off because of current events. We were working with, one of the good things about all the remote work is the different types of opportunities that are now available in Calgary. We have a lot of clients with headquarters in different parts of Canada, but also out of the US that are very rapidly coming to Calgary. So if that's of interest to anyone, feel free just to look me up on LinkedIn or shoot me a note, and happy to give you more details anytime.
Cool, thanks. Teammate is our long-term collaboration. If you're looking for jobs, feel free to consider reaching out to Rich. Um, all right, next I would like to thank Logic for supporting tonight's event. So Logic is a company that is working on automated security assurance. They're currently hiring for senior intermediate Python developers and junior React developers, and there are a whole bunch of other openings as well. Tugboat has expanded, pretty much tripled the size last year, 2020. So imagine what kind of accomplishment that would be. Feel free to apply or ask any questions. I can answer them. And also, if your company would like to collaborate, feel free to let me or Rich know so we can coordinate long-term or short-term collaborations. All right, today's talk. First, we're going to have this talk, Credit Risk Default, Learning from Kaggle Computation by Lin. And then the second talk would be how to conduct data projects with business and data understanding by Jiaqiang. The upcoming events. The first one is the Pi Cascades. It's a pretty famous event. It's online, of course, and it's going to be February 19th to 21st. And if you recall, last year the PyCon US was canceled because of the pandemic. This year it's back online in May. If you're interested, mark your calendar. And there are a lot more events in the Python org events, so feel free to check out this link. I believe they should all be online. Yeah, it can be good, it can be bad, but it's definitely a good way to learn and see multiple things. A few news. Python 3.8.7 is available. And just so you know, Python 3.8 is now the latest feature release. So you should consider upgrading your project as soon as possible. There is also a bug fix for Django, which is 3.1.5, and Django 3.2 Alpha 1 version has just released. Some articles for reading this month. The first one is Dockerizing Django with Postgres, Unicorn, and Nginx. It's pretty well documented for a detailed step-by-step walkthrough of how to Dockerize your Django web app and get ready for deployment. Um, I've seen people asking us questions about how to do deployment, and this is a pretty good article to read. The second one is 30 magic Python tricks to write better code. Well, this just shows some of the most frequently used built-in functions like counter, map, list, and so on. You should really know all of these tricks if you are considered using Python day to day. The third one is writing a simple factory method in Python. For those who don't know, factory method is a method that is well known for the design pattern. And you should really look up the design patterns to learn them. as much as possible because they're basically like the extracted structures from the experienced programmers for the past patterns. They're very, very valuable. The last one is 5 levels of handling date and time in Python. So date and time could be tricky in the Python world. This article shows the datetime module, the time calculation, time zone, and timestamps, and how to convert from the datetime object to strings. All right, as usual, we have these stats links here that you can click. And our next Python meetup is February 24th. So mark your calendar. And as we just discussed prior to the meeting, we feel like we should push the meetup a little bit late to about 7-ish so people can finish their dinner first. We usually have the Python meetup in about 6 or 6:30 because when we meet offline face-to-face, we can all have like dinner together and chat. But right now we can't do that, so maybe push that back is probably better. And yes, I will post the slides link to the chat very soon. We're always looking for presenters. Any topic, any experience level is very welcome. And especially if you're newbies in Python, you definitely should consider presenting because the best way to learn is to show what you learned and to teach people what you learned. And feel free to join the Slack, the PyYYC Design Develop workspace. And all right, I will pass it on to Lin.
Thanks, Carson. Just give me a second. I'm going to share my screen.
And do you want questions at the end or just as they come in?
Yeah, we can keep it interactive. That's fine.
Okay. Okay. I'll yell out if I see questions coming up.
Yeah, sounds great. Thanks, Rich. Anybody can see my screen, right?
Yes, you can see your screen.
Okay, great. Just highlight this and play. What's this? All right. Good evening, everyone. It's a pleasure to meet everyone online. So today, the talk I'm going to give is credit risk default, and this is a learning from one of the Kaggle competition. Before I jump into the talk, I would like to introduce myself for 30 seconds. My name is Lin He. I'm a quantitative risk analyst currently working for Synovus. Prior to that, I worked for TransCanada, Enbridge, and TransDelta, mostly on either the risk management or trading or business operations side. So I have been a quant for 15 years. And if you don't know what quant does, just think of me as a data scientist in the risk team. And before I present, I would like to share with you why I'm interested in doing this project. A little bit background, this project is already past the award timeline. So even though I do it, I won't be able to have any metal with me. But the thing about quantitative analysis is a lot of times you focus on the market risk. By that, I mean price risk. If the price goes up and down, how would that change your portfolio? How would that change your risk profile? Those questions are my day-to-day job. But I noticed a big trend in data science in that credit risk, the probability of somebody default is actually becoming very important. And one of the areas you might see is a lot of times when you purchase something online, they ask you to do the credit card transaction, right? And sometimes you will think, oh, it takes a little bit longer. And why is that? Behind the scenes, there are some machine learning model trying to predict the probability of default. So that's called fraud risk. And then credit risk can be more than that. Credit risk will be, okay, if this person has default, and what can we learn from his behavior to make sure that the next candidate we give loan to won't have the same situation? Or what can we be more proactive to alter their behavior so they can pay their bills on time and without risking that? So this is about credit risk. It's about really counterparty and default risk. So that's the distinction I would like to make here. And about this project background is sponsored by Home Credit. Home Credit is a consumer finance provider. Its business model is to provide loans to people with little or no credit history. So they can take the money to either decorate their house or build their house or use the money for goods, right? And even though it's very good for people that can receive those loans, the risk for home credit is obviously people might default, right? And if that's the case, then home credit will face this default payment, and which will impact their bottom line. And to share results with all the participants, Home Credit provide 7 data sets. And just I see there's no question so far, so I'm just go ahead and share the 7 data sets. You can see what do they have, right? So this basically their database giver, all in CSV file. The major one is this application. They have both the training data set and test data set. And for here, the most important thing in the training data set is they have the target variable. Yes means yes, the client has default. It doesn't make the payment on time or doesn't make the payment at all. And no means yes, no, this client still good. You can still do business with him, right? So this table alone has almost 100 features itself. And after that, you will see they really have lots of time series data in that, oh, they have data from bureau, and then you can see their credit bureau and their behavioral data here. And it seems like they are joined by a key called SKID, current. And then between the bureau and bureau balance is joined by SKID bureau as well, at bureau. And on the other hand, they have some historical data here. So this one is to do with the client's previous application, right? Well, how do they behave in the past? And then here, they also have point of balance, cash balance, installment, payment, credit card balance. I mean, the point is not to give you a picture of the domain knowledge, because even for me, I think unless you are really talking to people or you are in the industry itself, you probably cannot think of how the feature really play into your predicting variables, right? So my thought is, for a person that is not in the domain, how can I utilize this big data set to the maximum extent so that I can make sure I'm not missing anything? And having that in mind, I was thinking maybe the best way is to link all this CSV file into one giant view with probably hundreds and hundreds of features, but at least if I can join them by SKID current, SKID bureau, and also SKID previous, I will be able to have that view ready to go. And I don't have to just juggling with other data joining process. So this is the approach I was thinking. Join data by their common keys to merge all data set. This is step number 1. Step number 2 is exploratory data analysis. Step number 3, develop and build models. And then you apply on the test data set, submit to Kaggle to see how your ranking is. So to share a little bit of the result, my ranking is at the middle. So about 8,000 participants joined, but I was ranked 4,000. But that was given, I didn't do any feature engineering. So which means to win any Kaggle competition, I think feature engineering will be the key. By that, I mean transform the data to be something more meaningful to the prediction. That will be the secret sauce for successful Kaggle competition. And with that in mind, I would like to share my biggest learning by doing this project. And the first learning I will share is, how do I merge all these data sets together? And the second learning I'm going to share is for develop and building models, because I actually consider both random forest and XGBoost. So I'm going to have my thought, my notes, and a fun exercise with you at the end of the presentation. All right, let's keep going. So joining this data should be easy, right? We have Python, we have the pandas library, just do a merge based on the left and right key, and then do a key on something, right? Unfortunately, when I do this, what do I get? I got a memory error. It's complaining that, oh, no, we cannot process this amount of data. I think for any software engineering background, people with software engineering background, you always have two solutions for this problem, right? One is whether you want to replace your computer hardware, or you think of some algorithm that can optimize memory, right? I think the answer would be very obvious. You are not going to replace computer hardware anytime you run into this kind of roadblock. So this is exactly what I do. I searched online and found this person. He built a very nice function to reduce memory for the data set. So how does he do it? Basically, he's trying to figure out for each column, what is the minimum and maximum size of the data, and how many bits the maximum will go. And you just cap there. By doing that, it's just going to cap the capacity to just enough so that you can load the data without the extra cushion. And the reason behind this is by default, Python's memory is 64-bit. So if I only have a yes/no variable, for example, 0 or 1, I'm probably looking for only 8-bit. In this case, it will be 64 minus 8 is 56. I'm wasting the 56-bit that I don't need just for the cushion. And guess how the impact is after I do this memory reduction function? It's actually pretty impressive. Next slide. I got a 75% reduction rate for almost all the tables. So let's see. Using this import data file and then read data in chunks. And then we are going to use this reduce memory usage function. See, the memory starts with 624 megabytes. And then after this optimization is 156, 75% reduction rate. And after this, I don't have any issue joining any tables at all. So really just a function like that, I'm going back to the previous slide, just a function like this make a huge difference. I will consider any of you who want to do big data set or have various sources, consider this function. And the nice thing is once you have this as your standard library or something, you can always use that, right? It's really an option and it runs really fast. I don't see any questions so far, so I'm going to move to my second learning. Well, so now you have a lot of data set and you have lots of features, hundreds of features. Well, what will you come to mind? For me, it will be random forest, right? And actually, especially for decision problem, this is really something that maybe not the baseline for model you will think of, but definitely maybe step 2 or step 3. And so I use this opportunity to recap a little properties of random forest, including when should I use random forest, when should I not use random forest, and what does random mean in random forest. So the learning I have is, well, when do you use random forest? Whenever you can use decision tree, whenever you can use this if-else conditions. So for this case is if the credit history is X, the client's probably going to do Y. So this is a perfect candidate for decision tree. And then you can train decisions simultaneously so that it will become a forest, right? Because random forest is an ensemble method that you will have lots of decision tree. And if a bunch of weak voters come here to vote, it probably will end up with a very strong result, right? And that's the rationale behind. On the other hand, when would you not use random forest? For myself, I can think of 2 reasons. And one is if you want an exact explanation, you probably don't want to use random forest. So I just received the city's property assessment telling me how much my house is worth for. If you call them and they tell you that, oh, we just use random forest to predict how much tax how much your house is worth for, you probably will argue with him because you want to know exactly the reason behind. So in this case, if they say, oh, we use this linear regression model based on your land size, your square footage percentage of your house and the year of bill and how much decoration you have made and your neighbors selling that, you probably will buy into that more, right? Another situation is if you don't need any explanation. So you might want to use very strong machine learning algorithms such as neural net. You don't need to consider random forest. A typical example is if you can't read a doctor's script, right, a handwriting, you probably would say, hey, neural network, can you figure out what the doctor has written on my script, right? You don't need to understand why he wrote things certain way. You just want to understand what he write down, right? So just have this in mind. And then the third one I found very interesting, and I heard some of my friends actually got this asked during their data science interviews, is what does random mean in random forest, right? And the answer I can come up with, I know that there are some practitioners here, so maybe we can have discussion Q&A later. I think it's two perspectives. One is when your sample can be random, which means you might have 1,000 data points, but you only pick 500 of them, right, randomly. You don't have to use the whole 1,000 data points every time you train a decision tree. So that's one random. The other one is random features. So imagine if you have hundreds of features, you probably want to say, well, I want to cap it at 20 at most and see how this behaves. Because the key about random forest is you don't want to build a perfect decision tree. You don't mind to build some weak decision trees because combined together simultaneously, they will still make a strong learner. All right.
Lynn, there's a couple questions here just in the chat.
Okay.
Is that okay?
Yeah, that's fine.
How did you select machine learning models? And on DF memory, the helper function was looking at int and float. Is there one for strings?
I will answer the first question. How do you select machine learning model, right? I mean, the thing is, for machine learning model, there will be two kinds. One is supervised and one is unsupervised. So for me, I'm more familiar with supervised learning, and especially to do with finance. A lot of times you are dealing with really two questions. One is the continuous variable question that you're trying to predict. If that's the case, my thought will be always regression first, and then things like random forest or XGBoost. And if it's just asking you to predict yes or no, those probability prediction, my first baseline model is logistic regression. So just if I'm not sure how deep down you are with machine learning, but I would say that just linear regression and logistic regression would be your friend to start if you're dealing with very structured data or finance data, things like that. And I will answer the second question. I think there's a question here. Rich, sorry, what is the second question?
Oh yeah, it was on DF memory, the helper function was looking at int and float. Is there one for strings?
Yeah, yes, I think it has, but I maybe later after the presentation, I can share my GitHub to show the function, because I do have one for string, and then maybe you can take a look at that.
Perfect.
I'm pretty sure.
Just want to add a bit more to these two questions. The first one is, how do you choose models? This really depends on the project, on the data sets. So like if there are tons of data, let's say like gigs or even terabytes, you're probably better off with neural networks, because that's will give you more better results, more precisions. If you have short data sets, it's probably good with traditional models. And depending on your objective, it could be either like regression, as Lin talked about, or like classifications. So it's entirely different. What is normally done with selecting model is that you come up with a baseline model, which is that you fed the data into a series of models, and you choose a baseline, which means the highest accuracy, and then you like use that model as a baseline to determine how other models needs to be selected. And most of the time, it's not only just one model; it could be a combination of models. So It's there's a whole bunch of stuff related to that question. The second one is strings. It doesn't normally go with this helper functions because there are specific ways to deal with strings. It's more with encodings. So that's a little bit different question.
Sure.
Just want to
Yeah.
add on a couple details.
Yeah, I think both of the question will be worth at least an hour workshop. Great questions though, yeah. And so I will keep going with the, let me see. XG boosting. I'll keep going with my learning 3, XG boosting. So what exactly is XG boosting and why do I have that in mind? Because I was thinking, if you have a, like Carson was saying, you have a baseline model saying that you build some model, and then as you check the model again is your predictor, and then you know how bad or good you perform. And then you add this extra little function or little estimator to really perfecting your existing model. And a good way I can think of it is as a Toastmaster member, a good analogy I can come up with is I do a speech, right? And then I receive evaluation based on my speech. This is your new estimator. I incorporate this new estimator for my next speech on the same topic, which means my next speech, by theory, if I'm really listening, should be improved upon based on my first speech. So I think this is a key distinction between random forest and XGBoost. One is about simultaneously, you can do parallel computing, and this one is very sequential. The step matters, right? You can think of it as a time, right? It's just like previous time, current time, right? And I won't go too much into the XGBoost, but there are lots of papers on it. And to be honest, I don't fully understand a lot of them, but I just know that they have better performance and they are faster speed. It's a very good combination between software algorithm and hardware optimization. That's the very base that I know, right? All right, now I think I still have some time for a fun exercise to distinguish random forest and XGBoost, right? And we talk about random forest. Two things it means in random. One is the bagging, which means you select some samples, and the other one is you select random features. So in this example, I'm only going to use random means bagging here, and XGBoost, you will know soon. All right, so my fun exercise is, I think people can still see me, right?
Yep.
Okay. Great. I have this toothpick container, right? If you go to any Chinese home, it's probably very staple that you see that. And my ask for the audience is, can you guess how many toothpicks are in this container? Please type your answers in the chat. And I will ask Rich to be the helper. Can you not use all the estimate? Can you just cherry pick 5 audience answer for this question?
Do you want me to just call them out loud, or?
Can you please also calculate the average for me? So just randomly pick 5 of them.
Yeah.
Okay, just randomly pick 5 of them, and then tell me what you pick, and then tell me what the average is.
Okay, I'm just looking at the numbers now. 5, you said?
Yeah, just pick 5. Randomly pick 5. You can tell me the answer. I'm going to write it down.
Okay, you want the average?
Yeah, sure. We can start there.
So the average is 81.2.
Thank you. And the data point you have, we probably don't need this, Rich. Just have that in the back of your pocket.
Okay.
All right. So this is the bagging means in random forest, right? We have lots of decision trees. Every one of you have make a decision tree. And I asked Rich to help me to randomly pick 5 of them, right? So this is bagging means. And now let's switch to XGBoost, okay? And for this, because it's sequential learning, I want a volunteer to, maybe I will start with Dai Jones. You're guessing, and then I'm going to give 2 more chances to help you understand what XGBoost means. Okay, Dai Jones say there are 75 toothpicks in this container. And as a new estimate, I'm going to tell you that the number is on the high end. The number is too high. Next one, please. Dai Jones, you can try again. That's okay too. $56. Okay, Pat Danda, you told me that 56. So we already used 2 chances, one by Dai, the other one by Pat. And then I would say 56 is too low. Okay, so last answer, please.
Dai Jones has said 65.
All right, Dai Jones says 65. The answer is 62. So I hope this fun exercise help you understand the difference between random forest bagging and XGBoost. And I definitely hope that you can share as much my learning here, including how to optimize memory loading data. What is random really mean in random forest? And XGBoost sequential learning, and the key difference between random forest and XGBoost. Thank you so much.
That's great, Lin. We just got one more question. It looks like Dai's just asking if it's like binary search.
Binary search, which means yes, no.
Dai, do you want to just type a little more on that question if you can, just to help clarify?
Mm-hmm.
Oh, he says split the difference between high versus low.
Okay. That wasn't really XGBoost, right? Yeah. Anyway, I know that the next presenter is probably waiting for this.
Okay.
And if you want to privately chat to me, I think the function is enabled, right? Rich?
Yeah, you can message.
Yeah,
you can message.
Yeah, please go ahead and do that. And I will post my GitHub link online. So if you want to chat the projects, how I code it, grant you, I'm not the best Python programmer. I'm pretty sure Rich or Carson, a lot of people are better than me. But if you are like me,
overestimating me.
Pardon me.
I said I think you're overestimating me.
You have no idea how my program skill is. Anyway, thank you so much. Yes, GitHub. I will post my GitHub link on this chat, and then I'll pass the torch to Jia, right?
That's right. Jia, are you able to share your screen there?
Yeah. Okay. Okay. So can you guys see my screen now?
Yep, we can see your screen.
Okay. Thank you. Thank you for Lin's wonderful presentation here. Mine is more like a very basic one, like about how to do a data science project. So I'll just dive into my self-processing and how to finish my first project. So first, my presentation is about how to conduct a data science project based on the business context. And I'll post my GitHub, this project's GitHub profile here, and also my LinkedIn if you want to link with me. So first, give a self-introduction for myself. So I'm a recent grad from U of A with my master in chemical engineering, and before that I did a bachelor in chemistry. So like I will be honest, and like I didn't start to think about data science or like coding like 2 years ago, and then after that I realized this is my interest point. So I start to taking online course like at that camp and finish the track with Python, and then further attend like the data science boot camp at late, and like last August, I did one data science fellowship with Sabara for 1 month and working on one project with Nick Land College. And currently I'm still working on another Lalo degree with Udacity's data science Udacity. I feel that's pretty helpful. If you guys have other questions about this, please let me know. So my presentation here is more about like how to conduct a general data science project. And after we finish this, I'll dive into my GitHub profile to explain each step and also the post I write on Medium. So to finish a data science project is more about like first you need to define the problem and then collect the data and then clean the data, enrich the data, and then find the insight and then build a model and then reiterate this whole processing. But sometimes maybe it's the data comes first and then you define the problem. So it really depends. So here, the project I work on is I define two problems. One is like which manufacturer produce the most fuel efficient fleet of car. And there are two types, type 1 and type 2. I'll explain this. Type 1 is traditional. So it's like that there's only one type of fuels. Well, type 2 is like it's more like a mixed energy. It's like, for example, like oil and electricity, this kind of thing. And then with this, the second part is about how to build a model to predict the city mileage. So it's like that with this car, how many miles per gallon this car can run at the city road, which is also like the other model you can build is predict like how many miles it can run like at the highway road. And actually, like my first question can be directly answered by pivoting the table. There's no need to build up the model. That's what I want to see here. And then, so as for collecting the data was taken from the Fuel Economy Office from U.S. Department of Energy, and then it has the shape of 14,000 row multiplied by 83 columns, and they're both fluid, int, and object. And I'll explain how to deal with different type of data in the following that book. And then it's just reiterating, like finish the process and clean the data, and then get the insight and enrich the data, and then based on like whole business context. And in this process, you may need remove the irrelevant data and then get rid of the duplicates and also convert the data type and take care of the missing data. And then as for model, like we all know, like there are three types of things: clustering, classification, and regression. Well, for clustering is unsupervised learning, and then for classification and regression is supervised learning. And then it's just depend on like if your target is numerical or like categorical. If it's categorical, then it's classification. Well, here, what I want to predict is the city mileage. So it is regression, and then just to finish this process. So then I will go to my GitHub file. I think now you can see my GitHub. Okay. So first, to build up, it's definitely very essential or helpful for you to get into data science field if you have a GitHub profile and also presenting all the data science project you work on. So GitHub is more like some place that you put your code and then your thought process. But if like you are working with like the business leader, they don't care that much about like what exactly you did in this process. What they care more about is about your insight and then what you can get from this project. So which means that writing like business understanding post will be very essential. Here, like based on this project, I just built up a Medium post. It's about how to evaluate the fuel efficiency of vehicles. So like I discussed here, like how to which parameter may impact on their mile per gallon for the different type of car, like there may be their manufacturer, and also like the road, whether it is highway or city road. And then I list the question here I want to answer, and then give a brief introduction about the data, And then this is more like background. Like with this background, I pretty much can answer question 1 and question 2. And then for question 3 about the model, how to predict the city male age. So like I first analyzed the target. I realized, okay, the majority of data is like the falls between 5 and 15 miles per gallon. So this, like with this, I was thinking maybe there are some outlier. Like you can see, like some of them even have more than 200. Is that possible? Definitely, this will be something worth to check. And for the model selection, like as a beginner, I just went to like scikit-learn and then select those 3 like relative simple, like linear regression, supporting vector, and decision tree. That's also like I was asking the question before, like how to select those models. For me, it's like I just try these 3 and then it works okay. And with this model, like as I mentioned before, like there are 4 types of data points. One is float and int, and then ball, and also the objects. So well, to working with those model, I was just thinking maybe I just working with the numerical data, see the performance, and then I got the result here. As you can see, this is the evaluation matrix and like R2 score, explanation, variation score. These are all listed in the scikit-learn in evaluation matrix for regression. So, and it looks like the performance of linear regression and decision tree are pretty good with just the numerical data. And then to further see how will this works if I bring all the features, so I just use getDummy function and then converted all the categorical data into a numerical one. But like as you can see, like actually like the performance of linear regression has decreased. So it's not like that the more feature you get, the more complicated your data point get, your model will be getting better. But definitely like there is a slight increase of performance for the decision tree. And because I use the getDummy function, the memory usage has been increased from 25 to around 200 MB. So it's quite huge and it's very exhausting. Well, the reason I didn't list the supporting vector machine here is because it takes too long for it to output the result. So it definitely not a good model here. So this is what I want to share about the post. And then as for the other part, let me come back to the GitHub. So the GitHub profile I built here is like that I first explained what I did and also the processing and the README file and the library I used, project motivation. And also like this project was actually like a course kind of like assignment that where I was doing Udacity another degree, and then like it gives a lot of guideline about how to using the Grasp DM principle and Jupyter Notebook and the code structure. So I just need here as a reference. And then with this, let's come to the notebook. So the notebook I built is quite simple, as I explained in the post. So it's just 2 things. First is exploratory data analysis, where in this process it involves the business understanding and data understanding. It's more, the majority of the time, actually, they are just overlapping together. It's like you get a business understanding, come to the data, get to know data more, and then come back to further refine your business understanding, and then build the model if it's working good, and then get the conclusion here. So you can see there are so many features here. First, what I did is feature interpretation. And you can see there are some missing value for the columns, but the majority of them have, there's no missing value. And then to understand each feature, I did listed the information here. This is where I got the data set. And then a quite interesting thing I want to point out is like for type 1, you can see is single field vehicle, there will be only field. For dual, there will be conventional field. And then field 2 will be definitely will be for dual fuel vehicle. So it's like there are two, and then there are other data that is not necessarily important. For example, what I want to predict is like the city, the mile per gallon for city area, but there are also targets you can use like to build a model to predict for the mile per gallon on the highway. But I just keep it here. I mean, so to understand this data set, I'll first definitely the manufacturer will be very important. So I just export so many exporter. But you can see here is like what I want to prove is like for some car manufacturers, there are like 4,000 cars. So this data will be like considered will be very comprehensive. But for some manufacturers, there is only one. So will this data be necessary? Like when we further refine or apply to this model, this could be a question that we should ask. And then like for the field type, I also like output and visualize this result and analyze them, how they will impact and what's their quantity and get the non-value. And then after understanding the data, I just answer these two questions and get the answer like for type 1, like the most efficient is manufactured by Hyundai. Well, for type 2, the most fuel efficient is manufactured by Toyota. So then it's just the three model I selected, and I attached the link directly addressed to the model and how to conduct the fitting. So, okay, then come back. So, and as I explained before, like the first, in the first round, I just applied only numerical data and then understand that. But like there are some column you can see like there are more than half non-value. So my thinking is that since there are so many non-value, maybe it's not essential for us to keep it. Let's just do this first and see how the model perform. So, and like I build this function and then identify those and then just drop those columns. And then like after this, you can see there isn't that many, just have missing value. And then after further understand the data, I realized that actually like for these two features, like created and modified, it's just a login info. So it's not important at all. Therefore, I just directly delete them. And then to evaluate the model I built here, so I just go back to the scikit-learn evaluation metrics and selected these four, and then like for R2 score is like the closer to the 1, it will be better at explaining where Asian score is also the best score will be 1, and then the other two will be the lower the better. So, and then extract the data and build the model, and then for each of them I print out their performance and also their time for model training. And if like I mentioned before, like that both linear regression and decision tree performs well. Well, with NOR data, you can see like linear regression takes a little bit shorter time than decision tree, but with all the feature here, I use get dummy, and you can see it turn into 4,800 columns, and then like a lot of this feature will be redundant. I would say it's just how to further refine, and then I build the model with the same way and get the performance. So my takeout is like that linear model and the decision tree have both good accuracy and efficiency if it's applied for numerical data point here. And like but like if it's for all the feature, then decision tree will be performing better. So, and as we know here, like I already show, like since the performance is already like 99%, there's no need for us to bring in all the feature. So it's more like come back to the question. So if like the Department of Fuel Efficiency want to use this model, or the car manufacturer want to use this model to predict like how they can design or how they can regulate this kind of car, they may just taking in this numerical value and then go back and say predict how it works. I wonder if there's any question here.
I don't see any questions, but if anyone has them, just drop them into the chat or the Q&A. No, I don't see any questions, Jia.
Okay, thank you. Okay, then I'll just stop sharing.
Thanks very much. Did anyone have any? We'll just give everyone a minute because sometimes it takes a minute for the typing.
I think Pat has a question.
Oh yeah, there he goes. Yeah.
He hasn't typed yet. Just wait a bit. And actually, since we're here, just want to go back to the XG boost. Someone was asking, Di Jones was asking whether it was the binary search. Well, it looked like a binary search, but it was actually decision trees, which are, essentially different. Decision trees are like, you make a decision and the decision goes, let's say, have you had dinner tonight? You go with yes or no. So the yes or no, they are like the decisions you can make. So the XG boost was based on that. The binary search is a little bit different story. So it's like comparing the high and low values. It may look similar, but for XG boost, it's essentially different.
Okay, thank you for your question here. So the question is, did you use virtual machine instance or for model processing? So for this model processing, I'm on my computer. So there's a graphical processing ULED, but I don't think that's necessary because the data set is not that huge. Yeah, and sometimes while I was doing project or cost project, I'll just run on Google Colab. It's like if like the size is relatively larger and then it takes longer than I expected on my laptop. If it's given, I would suggest whether either you have an specialized machine or you're just using the cloud service. Otherwise, it would take too long for your laptop to work with the result. Yeah, and I believe like while I was attending like the Cyber Data Science Fellowship, they gave us an introduction about the Cyber Access Cloud. So if you are someone like living in Alberta and then you want to use that, you can just register an account with them and set up the ULED, and it's totally free.
Just want to add on to that a little bit. In fact, most of the time it's much easier to run on either Kaggle notebooks or Google Colab or on your computer because it's much cheaper. Both Kaggle notebooks and Google Colab give you like 30 hours per week of GPU or TPU instance that you can use for free. But if you actually would host your calculation files in EC2 instance, for example, then it would actually be quite expensive if you have like TB or PB files. So yeah. Do we have more questions? I think that's it.
Yeah, I don't see any other questions coming in.
Cool. Let's call it a night then.
Okay, yeah, thank you.
All right, yeah, thank you.
Great. Thanks very much.
Yeah, thanks so much, Lin and Jiaqiang, for this wonderful talk. Really appreciate it. And our next Python meetup is February 24th. And it'll be at around like 7-ish. I will send out notes as usual. So mark your calendar. And hopefully I will see you all next time.
Carson, I think there's one more question from Pat.
Oh,
Sure.
Yeah, he asked like, are EC2 instance are more common for consistent database pipeline processing?
Do you want to answer it?
So it's Pat asked, are EC2 instance are more common for consistent database pipeline processing?
Yeah, I mean, do you want to answer it?
No, I'm not sure about that.
There are certain pipelines like designed for this exact purpose. So we don't really use EC2 instance for that. There are other pipelines to do the exact same similar tasks. So in the short term, no. In the short answer, no. But if you want like build your own pipeline, then yeah, you can do that. Cool. If you have like any further questions, feel free to Slack me or just ask in the Slack channel. Otherwise, I will see you all next time.
Thanks, Carson.
Yeah, thank you.
Yeah, thanks so much,
organizing.
everyone. Thanks for coming and thanks for presenting. That was awesome.
Thanks.
And the video just needs to buffer, but I'll get it over to you soon, Carson.
Thanks. It'll be uploaded to YouTube in a couple of days.
Perfect.
Yeah.
All right, I'll end the meeting here. Have a good night, everyone.
Cool.
You too. Good night.
Thank you. Bye.